You know the situation. You run your application locally in dev mode, you hit refresh, your application works. But then you push it to production and oh no, what is going on? In this video, we're going to take a look at a pretty cool feature and use case for ngrok that will help you get rid of this situation, or at least make debugging it a whole lot simpler. Let's have some fun. Now, even though I know that you have 100% test coverage across unit tests, integration tests, acceptance tests, smoke tests, canary tests, chaos tests, performance and synthetics. And you'll also definitely have observability with logging and tracing and metrics, exemplars. Don't forget continuous profiling and dashboards sprawled across 12,000 screens in your NOC, maybe your bedroom. Let's be real. Software isn't always ideal. We have tech debt, and more often than not, we need to take on some acceptable risks and cut some corners. And you can't tell me that you haven't deployed a temporary container or process in production with a test build to check if something is fixed, or sometimes even to help debug weird edge cases. So let's see how we can do this in a safe way to help mitigate the time and effort that it takes to debug real production edge cases using a fantastic tool that is ngrok. I use ngrok across my entire production infrastructure, and this is just one of the ways that it saves me time every single day. So let's set the scene. So here, I'm working locally on my Go project. The web server is running on port 8080. We jump over to the web browser. We can hit refresh many times as we like, and it continues to deliver the response that we expect. This application is super simple and it is just dumping out all of the HTTP request information that we have to the screen. Now what happens is we push this to production, and now we're getting an error message from our ingres, which in this case is ngrok, telling us that our server is returning an invalid response. Potentially, our application is crashing. What we're going to do to debug this is run our application locally again. However, we're going to use ngrok traffic policies to say that we want a small subset of the production traffic not to go to the production pods, but to come to our local machine. So let's start shipping our first traffic policy. So this is the YAML for our deployment. It's running my simple HTTP demo image, which is pulling from GHCR. It listens on port 8080, and it has a service that exposes it with the same name of demo on the same port of 8080. So now if we jump over to our traffic policy, the first thing we do is define an agent endpoint. This is how we configure the ngrok operator within our Kubernetes cluster to add some sort of routing to a workload within our cluster. What we're seeing here is that this agent endpoint is called demo, and we're giving it the name demo.internal. There are three types of binding for an endpoint within ngrok: internal, public, and Kubernetes. We're not going to take a look at the Kubernetes stuff today. We're going to do a whole video on that very, very soon. Right now, we're saying that we want to have an internal endpoint, and this is going to be upstream to a Kubernetes service within a cluster. Notably, demo.default.service.cluster.local on port 8080. Now that ngrok knows how to route to that because of the agent endpoint, we need to then make it available to the big bad internet. And for that, we can use a cloud endpoint. And I'm saying I want this cloud endpoint, which is also called demo, to be available on demo.rawcode.academy. Now we're going to add a traffic policy here because we want to be able to tell it how to route the traffic. For this, we're using a forward internal to the demo internal endpoint. All that means is that when I hit demo.rawcode.academy, it's going to our demo service in the cluster. So let's modify this. We know our application is failing and we want to get a local workload to receive traffic. Now, there are a few ways that we can do this, but first we're just going to start by saying on error, continue. If for whatever reason we can't deliver a response on the production pod, I want to forward it somewhere. And for that, I'm going to say raw code.internal. This just means I'm going to provide a new internal endpoint called raw code. We can come here and say apply a traffic policy. Now, right now we don't have an ngrok.internal, so let's do ngrok HTTP, and we're going to use port 8080 because we're running our Go application locally on port 8080, and the domain will be rawcode.internal. I am now running an ngrok agent to provide the raw code internal endpoint. So what should happen now is when I run my just script, which is just curling demo.rawcode.academy, we see up here on our Go application that we received a request. Perfect. So now that was successful. Let's run it again. And finally, we catch the error that we're getting in production. We can see here we have the panic. It's not consistent, but now we get to debug. And unfortunately, this is where I get to disappoint you. If we come to the code, you'll see that we have a 50-50 chance of hitting an error. Now, I understand this is extremely contrived, but the edge case isn't important. The workflow is. Using the traffic policy, we can detect errors and route locally to do whatever kind of debugging we need to do to resolve the issue. However, on error isn't the only way to route traffic to my local machine. Let's take a look at other ways to utilize traffic policies with ngrok. So here I have a README file. I will make this available via GitHub and put a link in the description below. We've already seen the first policy where we can forward internal to whatever endpoint we want. However, with ngrok, we also have access to expressions used in common expression language, cell. Here, I can actually build a kind of pseudo A/B test where I have a 50% chance of hitting one or more endpoint. Here, I'm saying generate a double, and if it's less than 0.5, forward to raw code internal. Hopefully giving me an even split of production traffic with the production pods. This last one at the bottom, we have a slightly different expression. This time, we're pulling out an HTTP header called dev. And if the value of this header is equal to raw code, I can use this to forward very specific traffic to me. Meaning, if I want to test in production without affecting any production traffic, I can use synthetic requests with my header to route my traffic to my local machine. And this is just scratching the surface of what ngrok makes available. If we go to the ngrok traffic policy documentation, you can click on Actions, where you can see all the different steps that you can take to route traffic, whether that be to add headers, do basic authentication, JWT or JOT validation, OAuth integration, which is my favorite action, rate limiting, redirects, restrictions via IP, even SAML. If we click on examples, we can see how to do A/B tests, block the AI robots, and if we click on the expressions concept, you'll see we have access to a whole bunch of different variables, a whole bunch of macros, even the action variables, and we have some fantastic examples that allow us to match on headers, paths, geolocation information, and so much more. So go check out the ngrok documentation if you're interested in learning more. As you can see, when you use ngrok in front of your applications to deliver the traffic, you're able to tap into a whole plethora of amazing features. Some that will help you debug in production, others that let you secure your roots or whole applications, and a whole lot more features that we'll be covering very, very soon on new ngrok videos coming to the Raw Code Academy. So check out the links and description below, simplify your life with ngrok, and have a wonderful day. Until next time.